All right, so has anybody ever heard of scientific notation?
No.
Okay. Yes.
I've actually done it.
So here's how this works. Okay, first of all, we're going to define scientific notation. Okay, scientific notation is basically, it's a way of expressing very large or very small numbers. Okay? And it is always done. You guys writing this down? Okay? It is always done in powers of 10. Okay? All right. So when we have scientific notation, okay? Let me show. Does everybody have that written down?
No.
Okay. I'm going to first show you how to express a number in standard form and express it as scientific notation. Then we'll do the reverse. Okay? All right. So does everybody have that written down?
No.
Okay. Let me know when you're done.
I'm done.
Is everybody done? Okay. So first of all, any number that is like a normal number, okay, that's considered standard form. Okay? If I said how far is it if you were to drive from here to Dallas, Texas? You might say 1,000 miles. Okay, that's a standard number, right? Okay. Now, when we have very large numbers, okay, first of all, we're going to go from standard to scientific notation. Okay, so if I have a number like this, let's say I had 93,400,000. Okay, and I want to express this in scientific notation. Okay, that's a large number, right?
Yeah.
What we're going to do is we're going to first read this number from left to right. What is the first non-zero number I see? 9. Okay, so you're going to write that down. 9. And whatever that number is, we're going to put a decimal after it, and we're going to continue with all of the rest of the non-zero numbers. So what comes that's after this 9 that's not a 0?
3.
So 3, and what else?
4.
Okay, so 9.34. Okay, now looking back at your definition of scientific notation, all scientific notation is expressed in powers of what?
10.
10. Okay, so we're going to multiply this times 10. Okay, now this 10 is going to have an exponent up here, and it's going to be dependent on where you place the decimal. Now, here's the thing. This number right here must be between 1 and 10. Is 9.34 between 1 and 10? Yeah, so we're good there. Okay? If this was 93.4, that would not be considered scientific notation. Do you understand why? Because it's not between 1 and 10. All right. Now, let's go back to this original number. Where did we place the decimal? Between what and what?
9.
Between the 9 and the 3. So we're going to put a line there. Okay, and then we're going to count the digits to the right of where we put that decimal, which would be 1, 2, 3, 4. Oops, 1, 2, 3, 4, 5, 6, 7. Okay, that is going to determine what our exponent is. Okay, that's pretty easy, right? Okay, all you have to do, you find out where the decimal goes, first non-zero number. Okay, then you multiply it times 10, and your power is determined by how many digits to the right of where you put the decimal. Let's try another one. Let's say I had 6,200. Okay, what is the first number I see from right to left that's between 1 and 10?
6.
So 6 point what?
2.
Times 10. Now, if I put this, what did I do? What do you think I did? This is wrong, by the way. What did I do? You count the zeros. Okay, you can count the zeros only if that number is a single digit. Okay, so the rule of thumb, don't count the digits. Don't count the zeros. Okay, so we're going to get rid of that 2. Where did we put the decimal? Between what two numbers? Okay, how many digits to the right?
3.
So 1, 2, 3. So what's my power of this 10 going to be? 3. Okay, good. You can express small numbers in scientific notation. Let's say I had 14. You think I can express this in scientific notation?
Yes.
Yeah? What's the first number from left to right that's between 1 and 10? 1. So 1.4 times 10, if I put the decimal here, how many places did I move it?
Just 1.
So 10 to the 1, or 10. What's 1.4 times 10? 14. Okay? Does that make sense? Okay?
Yes.
What's your question? Okay. You read this number from left to right. The first digit that you see that's not a 0, you put it down, you put a decimal, and you list all the other non-zero numbers. Okay? We'll do another one. Gabby?
Can you, multiply 10? Because you didn't do it on the board. So.
You don't have to actually multiply it out.
Okay, so you just have to write
You're
10
just
down.
expressing it. Yep.
Okay.
Yep. Okay, look, we're going to do another one. Okay? All right, you guys follow along. Okay? Stay with us. Okay, let's say I got 1,114 or 1,140,000 as a number. Okay. Bowman, read that number from left to right. What's the first non-zero I see? 1. And I'm going to put a decimal after it, right? Right? Now, what are the rest of the non-zero numbers? 1, 4. Okay? Do you guys see where that came from?
Yes.
And I'm going to multiply this times the power of 10. And I determine that exponent by, where did I put that decimal? Between what and what?
The 1 and 1.
Right here. And how many digits are to the right of it?
6.
1, 2, 3, 4, 5, 6. Okay? Does that make sense?
Yes.
Yeah? Okay, now, sometimes, Jewel.
Why is it 1.14?
Oh, because
Right. Now, sometimes you have a number that's separated by a 0, meaning there's a 0 between non-zeros. What does that mean? Let's say I had something like this. 402,000. Okay? I'm still going to do this the same way, except I'm going to include my 0 as part of my decimal. What does that mean? Well, what's the first number I see from left to right that's not a 0? 4. Point, but now I'm not going to put 4.2 because that would not be correct, would it? What am I going to do? 4.02 times 10. How many digits? To the 5th power. Okay? Give me a thumbs up if you understand what that means now. Where did I get the exponent? Like the 5? Because where I put the decimal is right here. I count how many digits to the right. Okay? Natalie.
what if you had a number that was 1,122?
Okay. 1,122. Like this?
Yeah.
Okay, I'm still going to do 1.122 times 10 to the 3rd power. Okay? Make sense? Okay. All right. Are we good on this?
Yes.
Okay. How many have you ever seen on a calculator, and you don't have to have a calculator to do this. I'm just going to show you what I mean. Let's say I had a really huge number. Let's say I took 999,000 times 856 times 6. Okay. What's showing on my calculator is this. 5.1359, and then all you see at the end of the number is this. Okay? What do you think that means? That means it's going to be expressed. This is not this number to the 10th power. That means I'm going to express this in scientific notation. So 5.1359 times 10 to the 10th power. That's what that means. You might also see it as this. Some calculators would show this same number, 5.1359, and then E10. What do you think that means?
Exponent.
It means exponent of 10. Okay? That means this would be 5, the same thing. 5.1359 times 10 to the 10th power. Okay? Does that make sense? Okay, now, next part. Okay, what if I have something like this? This is standard, this is scientific notation. Okay, I told you this is a way of expressing very large numbers, right? Well, what also did I say? Very small numbers. Okay, so let's say I had something like this. 0.0000231. Okay, write that down. Okay, I'm going to do this the exact same way. I'm going to read it from left to right. What's the first non-zero I see? 2. Decimal, what are the other non-zeros I see? So 2.31. And this, so far, is exactly like what we've been doing, right? The only thing is, what does this number start with? What does it start with? A decimal. Okay, so we're going to go back and we're going to put a line where I place that decimal, which is between the 2 and the 3. Okay? But I want to count to the beginning of the number. Well, think of a number line. If I go that way, what's it going to be? Okay, so I'm going to count how many digits to the left. 1, 2, 3, 4, 5. But it's not 5 to the right, it's 5 to the left. So what do you think that's going to be? To the negative 5. Okay? Yes. Question.
So like if you were trying to convert like from scientific notation to the standard.
We'll get to that. Hold on. It's easy. It's super easy. I'll show you in a minute. Question.
I thought that you can't have negative exponents.
Okay, if it's in scientific notation, you can. Because you can easily convert it back to standard. Okay? All right, did you guys understand what we did there? Try this one. Try this one. 0.00429. Write that in scientific notation. Well, you're not necessarily going to. I mean, if you're doing one way, you're going to express one as the other. Okay? Who has an answer? Okay, about half of you. Okay. Zuri, left to right. What's the first number I see that's not a 0? 4. What do I put after that? Okay. And what do I do next? Put my line between where I put what? Okay, how many are to the left? So a 10 to the negative third. Good. How many of you got that right? Trey, why don't you raise your hand? Did you get it right? Okay. All right. Are we good on that? Okay, now the other part, everything we've done so far, we've taken a number from standard and turned it into scientific notation. Now we're going to do the reverse. Okay? So we're going to take some numbers and we're going to change them from scientific notation to standard notation. Okay, let's say I got something, let's say I got 2.34 times 10 to the 5th. Okay? Why might somebody do that? What did that person do?
Something wrong.
Okay, what did they do, Jackson?
They only counted zeros.
They just put 5 zeros after it. While that's a nice try, it is incorrect. Okay, don't do that. Here's what we're going to do. Okay, when we write a number from scientific notation to standard, okay, is everybody tracking with me? First thing you do is you write that decimal number. So what is that decimal number? 2.34. Write that. Okay? Now, this exponent here, is that positive or negative? Okay, so positive, everything like a number line, is going to go which direction? To the right. So we're going to put our pencil on this decimal, and we're going to move to the right how many times? 5. Why? Because my exponent is a 5. So 1, 2, 3, 4, 5. What do you think we're going to fill in those spots with? Zeros. Okay, now when you do this, it looks kind of messy. So we're going to rewrite it as a nice, neat number, 234,000. Okay? Isn't that easy?
Yes.
Okay? Try this one. Let's say I have 8.02 times 10 to the 7th. Let's see if you can write that in standard form. Okay? I have 2 with an answer. I have 3, I have 4, I have 5. Okay? Audrey, help me out. What should I write first here?
8.02
Okay. And then I put my pencil where?
on the decimal.
And I move it how many places?
7.
Can I just put 7 zeros? It's the same thing, right?
No.
No. What do? 1, 2, 3, 4, 5, 6, 7. What do I fill in those spaces with? Okay. And I'm going to rewrite this all nice and neat. 802000000. Put a comma here and a comma here. Okay, how many of you guys understood that? Pretty easy, right? Okay. What's your question?
Okay, so going back to the first example you had,
Mm-hmm.
why is there not 5 zeros?
Because this 5 stands for where we put the decimal at. Okay? That means that there's 5 spaces to the right.
Thank you.
Okay? All right, so let's take a look at another one. And tell me what is different if I have 1.05 times 10 to the negative fourth. What's different about this one? Obviously, there's a what?
Negative.
Negative exponent. We're going to do this the exact same way, meaning we're going to write this number 1.05, and we're going to put our pencil on the decimal, but instead of going right, where are we going to go? We're going to go left. How many spaces? 1, 2, 3, 4. What's going to, now, what we have to remember, if we go left, we're moving a decimal. What has to go in the very front of that number? The decimal. And what are we going to fill in those empty spaces with? 0. So this would be 1, 2, 3. You can rewrite it so it's nice and neat. 0.000105. Okay? Does that make sense? And just to show you why this is what it is, okay, you're not going to have to do it this way, but I want to show you why. This would mean 1.05, and you guys asked me you can never have a negative exponent, which is true, okay? If I was to get rid of this negative exponent, what would I rewrite this as? 1 over what? 10 to the fourth, okay? Which means 1.05 times, okay, what's 10 times 10? 100 times 10. 100 times 10. 100 times 10, 1,000. Times 10. 10,000. Okay? That's what this means. This means 1.05 divided by 10,000. Well, if you were to do this, you would get this. Okay? Does that make sense why it is now? Okay? Your book illustrates it kind of like this. Okay? To me, it's easier to do when you're dividing by tens. Any power of 10, it's easier to just move a decimal. Okay, does that make sense? God bless you. Any questions at all? Are you good on this? Do you need any more examples?
No.
Okay.